All right, lesson 4 in our transformations unit, we're looking at reflections of figures on the coordinate plane. A little warm-up activity here is just emphasizing what happens when we multiply a number by a -1. Essentially, we're just changing the sign of that value. So number 1, -1 times 6 is going to give us -6. -3/5 times -1 now becomes +3/5. -1 times 4.33 becomes -4.33. And then 4h times -1 becomes -4h. So we'll use that concept here coming up when we talk about reflecting across an axis and signs changing. So our goal is here, reflect geometric figures on the coordinate plane, identify and describe the effects of a reflection on a two-dimensional figure using coordinates, and identify congruent figures by obtaining one figure from another. All right, a little getting started activity. We're not going to spend too much time here. Just giving the idea of what a reflection is. Think of when you look in the mirror, everything's opposite of what it looks like. That's what they're showing here with this figure. So for instance, if you were staring at yourself in the mirror and you hold up your right hand in the mirror, it looks like the figure is holding up its left hand. So everything is a flipped image of what it appears like. All right, so activity 4.1, modeling reflections in the coordinate plane. So in this activity, you will reflect pre-images across the x-axis and y-axis and explore how the reflections affect these coordinates. Now, it says use patty paper. Patty paper can be a little difficult with reflections in my experience, getting it to fold exactly along the axis. So I'm going to emphasize more so just the distance from the axis of each point when we reflect it. So if we reflect figure J across the x-axis, so we're reflecting it across this axis now, and then complete the table. So, for instance, point B. When we reflect something, it is symmetrical going across that axis. So if point B is 1 unit away from the x-axis, it's going to move to 1 unit on the other side of the x-axis. And the same can be said for all the other points. So point A there is 5 units. Sorry, excuse me. No, it is 5 units from the x-axis. So it's going to reflect to 5 units from the x-axis going the other direction. And so on. I don't know why that is moving when I touch it. Let's try that again. There we go. All right. Pen was acting up there a little bit. So and so on. Each point would move to its coordinate place. C would move to there. D is 3 units across the x-axis, so we're going to go 3 units below it to reflect it. E is 4 units from the x-axis, so we go the other way, 4 units, 2, 3, 4. And then F, I'm going to go back with blue again. Let me zoom in here. It might make it a little easier. F is 6 units on the positive side of the x-axis, so we're going to go 6 units onto the negative side of the x-axis. And we would get our figure. If I were to draw that in, all my points moved a little bit. So let's get it about where it should be. So we would get our figure that looks about like this, if my drawing was perfect. There we go. All right, but that can be difficult as far as just trying to count the points and move it. So we have a rule we can use when we're talking about reflecting across the x-axis. When we're reflecting across the x-axis, we're moving vertically up and down. So we're changing in the y direction. So the x value doesn't change, and the y becomes negative, flips. So if we want to name the coordinates of the new figure, the x value in each one of these is going to stay the same, and the y value is going to change. So that becomes 2, -5, 2, -1, 4, -1, 6, -3, 5, -4, and 6, -6. Okay, so we can use that rule anytime we're reflecting across the x-axis. So question B, compare the coordinates of J, of the new J, with the coordinates of the pre-image figure J. How are the values of the coordinates the same? How are they different? So again, the x value is unchanged. And the y is the inverse. Changes signs. Okay, moving on to the next page. Now it says reflect J across the y-axis. So again, if we were to go back to that figure and reflect it now across the y-axis, we would do the same thing but moving horizontally, be moving left. So again, we could go count the distance, like for point B here, it's 2 units on the right side of the x-axis, or y-axis, I'm sorry. So we'd go 2 units onto the left side, and so forth. And we can move each point again, but once again, we have another rule we can use. So if we're now moving horizontally to reflect across the y-axis, we're moving in the x value direction, left and right. So what we have to do to reflect across the y-axis now is the opposite of what we just did to reflect across the x-axis. So our rule is we're going to change the x value inverse. We're going to change the sign of the x value. So if we go back, our new rule to reflect across the y-axis is negative x, and now the y is staying the same, staying constant. So we can go change all these points to reflect it across the y-axis. So we have negative 2, 5, negative 2, 1, negative 4, 1, negative 6, 3, negative 5, 4, and negative 6, 6. Okay, so that rule enables us to quickly find the new coordinates based off reflecting across the y-axis. So follow-up questions similar to the last one. Compare how the coordinates of the new figure J with the coordinates of the pre-image J. How are the values of the coordinates the same? How are they different? So now this time the x value is the inverse and the y value is unchanged. All right, moving to our next one. It says, let's consider a new figure that's situated differently on the coordinate plane. So what makes this different is we now have parts of the figure that are in multiple different quadrants. That's where these rules really come into play about changing the coordinates to find the new figure. So if we're going to complete the table of the coordinates of the reflection, and it's telling us to reflect it across the x-axis. So if we go back to our rule we used, to reflect across the x-axis, the x is unchanged, and the y value is changed. So if we want the new coordinates again, so for point P, the x value is unchanged, the y value is the inverse, so it becomes negative 1. For point Q, x value is unchanged, y value becomes negative 2. For point R, x value is unchanged, y value now becomes positive 4, the inverse of negative 4. And for point S, the x value is unchanged and the y value becomes positive 5, the inverse of negative 5. So again, if we wanted to plot those points of our new figure, negative 1 would be there. Then we have 2, negative 2 would be here. 0, 4 would be here, and negative 3, 5. Negative 3, 5 would be there. So we would get a new image that looks about like this. And that would be reflected across the x-axis. So a little more work if you were to try to do it by hand when the part of the figure is in different quadrants, but using that rule makes it much simpler to find our coordinates. So B, compare the coordinates of the new quadrilateral PQRS with the coordinates of the original quadrilateral PQRS. How are the values of the coordinates the same? How are they different? So again, it goes back to our rule. If we're reflecting across the x-axis, the x is unchanged, and the y value is the inverse. Okay, it's changed signs. All right, now we're going to take that same figure and we're going to reflect across the y-axis. So again, it says A, make a conjecture about the ordered pairs for the reflection of the quadrilateral across the y-axis. So again, we should see an inverse of x and y unchanged. So that's our rule for reflecting across the y-axis, because now we're moving in that horizontal direction, the x change. All right, so again, new points. P would now become positive 1, the inverse of negative 1 for the x, and the y is unchanged. So 1, 1. Q would become negative 2, 2. R, now, there is no inverse of 0, so that's going to remain 0, negative 4. And then for S, it would become positive 3, negative 5. So that 1 point, since it's right on the axis there and we're reflecting across the axis, it's not going to change. So compare the coordinates of quadrilateral of the new PQRS with the coordinates of the pre-image quadrilateral PQRS. How are the values of the coordinates the same? How are they different? Again, same reasoning. The x value is going to be the inverse. The y value is going to be unchanged. And if you want to make a note of with exception of point 0, negative 4 that is on the y-axis. Because if we're reflecting across the y-axis and we have a point on the y-axis, that point is not going to change at all. All right, activity 4.2, reflecting any point in the coordinate plane. So again, this is getting back to those rules I've already been introducing you to. So it says use the table to record the coordinates of each point, reflect the graph of point x, y across the x-axis. What are the new coordinates of the reflect the point of terms of x and y, and then reflect that same point across the y-axis. So again, it goes back to our rule. If we're reflecting across the x-axis, the x is unchanged, and the y becomes the inverse. Then the opposite is true. If we're reflecting across the y-axis, so now we're going that direction, the x value is now the inverse, and the y value is unchanged. And that would give us the new points after the reflections. All right, next page. Now we're getting to where we're just given the points. We're not given the image. So graph triangle ABC by plotting the points 3, 4, 6, 1, and 4, 9. We'll do that first. So 3, 4 would be there. 6, 1 here. 4, 9 would be here. So there would be our triangle. So use the table to record the coordinates of the vertices of each triangle. And we're going to reflect it for question part A here. We're going to reflect it across the x-axis to form a new triangle, ABC. Graph that triangle and then list the coordinates of the reflection. So first, let's write the points that we're going to reflect it to. So for the x-axis, reflecting across the x-axis, that's where our x is unchanged and our y is the inverse. So we're going to have 3, negative 4. 6, negative 1, 4, negative 9. So if we go back to graph those now, 3, negative 4. Then we have 6, negative 1. And then 4, negative 9. So here would be that figure reflected across the x-axis. And now if we reflected it across the y-axis, now we're using our rule where we have the inverse of the x and the y is unchanged. Okay, and that's how I tend to remember the two rules. If I'm going across the y-axis, my y doesn't change. If I'm going across the x-axis, my x doesn't change. So our new coordinates, again, basing it off the original again, we're going to have negative 3, 4. We're changing the inverse of the x. Negative 6, 1. And negative 4, 9. So if we were to graph those, negative 3, 4 would be there. Negative 6, 1 would be here. And negative 4, 9 would be here. So there would be our reflection across the y-axis, given those coordinates. All right, so now we're given a very similar problem, but we're not given the graph. But that's okay. We can use our rules to write the coordinates of the new point. So we're given triangle DEF, and the points D, E, and F. So it says if DEF is reflected across the x-axis, so we're using our rule x, negative y, what are the coordinates of the vertices of the image? So D is going to change to -7, -10, and we change the y value to the inverse. E is going to be -5, -5. And our new F coordinate, again, x is unchanged, -1, and that'll become +8. So there would be our new coordinates. Okay, B, how did you determine the coordinates of the image without graphing the triangle? Using our rule of x, -y. To reflect across the x-axis. Okay, C, if triangle DEF is reflected across the y-axis, what are the coordinates of the vertices of the image? So again, same thing, but we're going to use our rule for the y-axis, which is inverse of the x, keep the y the same. So our new D value, going back to the original coordinates, back at the top, -7, 10 is going to become +7, 10. Our new E, -5, 5 is going to become +5, 5. And our new F, -1, -8 is going to become +1, -8. So the y values were unchanged there. So how did you determine the coordinates of the image without graphing? Again, goes back to our rules. -x, y to reflect across the y-axis. All right, next activity 4.3, verifying congruence using reflections. So again, remember back to our lesson 3 lessons ago talking about introducing all the rigid motion transformations. Rigid motion transformations, reflections and translations we've looked at so far do not change congruency at all. It doesn't change the size or shape of the figure. So number 1 says, consider the 2 figures shown. Complete the table with corresponding coordinates of each figure. So for J, in the original figure, I'm going to say, yes, the shaded one is the original one. So J is at 2, 2. M is at 1, 0. L is at 2, -2. And K, 2, 3 is at 4, -1. Okay, so if we now put the coordinates of the new figure, J is at -2, 2. M is at -1, 0. L is at -2, -2. And K, new K, is at -4, -1. So it wants to know, is the new quadrilateral congruent to the original one? And the answer is yes. It goes back to our rule. If we're translating or reflecting it across the y-axis, which is what this image looked like, it's reflected across the y-axis, we're using the rule -x, y. And if you go through each one of those points, like J, the original 2, 2, if we apply that rule, it becomes -2, 2. Okay, M, 1, 0, we apply the rule, it becomes -1, 0. So as long as the corresponding vertices have been reflected all equally using that rule, then yes, it is still congruent. All right, moving on to our next page. Number 2 here, it says, study the figures shown on the coordinate plane, determine whether each pair of figures are congruent, and then describe the sequence of rigid motions to verify your conclusion. So is figure K congruent to the new figure K? So if we're looking at figure K, what it looks like is we've had a reflection, and then new K has been translated up 1 unit. So if you measure each vertice, if you were to track each one, you would find that if you move the points down to here and then move them all up 1, it would follow our rule. Reflected across the x-axis, we would have x negative y, but then it was shifted up 1. So yes, K was translated down 1 and then reflected across x-axis. And it wouldn't matter if we said it was reflected first and then translated up 1. You'd end up with the same result. Both would be correct. For B, is figure P congruent to new figure P? Okay, well, if we're looking at those, not only do I see that we have a transformation where it's been translated, but if you measure the corresponding vertices, they do not match up. If we take each one of these and reflect it across the y-axis using our rule negative x, y, and then it looks like there was also a translation to the left from the original unit, because our point here would stay on that y-axis. But when we do that, we do not get corresponding vertices. If you were to track each one, take patty paper, trace it, or just track each one using that rule and then try to see if they were all translated equally, you would find that no, they're not. Okay, and just to give you a more drawn out example, I'm going to write each coordinate and then we're going to write the new coordinates and see if they correspond. Erase it where we can get each one. So original E is at 0, negative 2. Original A, it looks like they've named that point, is at 2, negative 1. Original B, 4, negative 2. Original C is at 3, negative 5. And then original D is at 1, negative 4. Okay, so let's take those points and first apply the rule where it looks like it has been shifted 2 to the left. If we count these units, 1, 2. So 2 to the left would be minus 2 to the x. So if we take that, minus 2 to the x value, this point becomes negative 2, negative 2. This point becomes 0, negative 1. This point becomes negative 2, I took away more than that. Taking away 2 from 4, we get at 2, negative 2. Take away 2 from 3, we're at 1, negative 5. And take away 2 from 1, we end up at negative 1, negative 4. Okay, so there was the move to the left. And then if we follow the rule to reflect it across the y-axis, we should have a negative x and the y unchanged. So I'm going to squeeze them in here in a different color. So this should become positive 2, negative 2. The next one should become negative x, so that doesn't change the x. Reflect it, so negative x, negative 2, negative 2. Negative 1, negative 5, changing the x value again. And then this one, the negative 1, will become positive 1. And now if you try to match those up, those will not match the points of new figure P. Okay, so there's kind of a long drawn out reasoning why, but no, they will not be congruent anymore. And then the last one, figure T, is figure T, original image T congruent to new figure T. Well, if we look at t, it looks like it has been reflected across the y-axis and it has been translated up 1 unit. If we move each one of these up 1 unit to there, this one up to here, and this one up to here, and then use our rule to reflect it across the y-axis, so negative x, y, you will find yes, they are congruent. And our reasoning would be translated, lost my, if you didn't get that filled in, just rewind it. Rewind the video so you can get that filled in. So yes, it was translated up 1 unit and reflected across the y-axis. All right, on to our last page. Again, just reflecting on what we've been talking about, reflecting on reflections. Describe how the order pair x, y of any figure changes when it's reflected across the x-axis. So just reiterating our rules, when reflected across the x-axis, the x is unchanged, and we have the inverse of the y. And then the opposite for number 2. When reflecting across the y-axis, the inverse of the x, and the y is unchanged.